Hey guys, in this video we're going to take a look at interior angle measures in polygons. So to start off with the definition, interior angle of a polygon is an angle that faces the inside of a polygon and is formed by consecutive sides of a polygon. Something that they can ask you to do is ask you to find the sum of all the angles of a certain polygon, or to find the measure of just one of those angles in a polygon. And we're going to take a look at finding a rule for being able to find that measure without having to count every single time. So the way they come up with the formula is they started with the shape that we know fairly well, and it's a triangle. When you look at a triangle and we're talking about measures of the degrees of the angle, we have our triangle sum theorem that says that the angles in a triangle all add up to be 180 degrees. And if you're looking at a triangle, it's got three sides. So if you look at a square, and they could also call it a quadrilateral, and that would apply to squares, rectangles, and other things that have four sides. When we look at those have four sides, and they wanted to find the number of degrees in them. And when you're looking at quadrilateral, you don't necessarily have the 490-degree angle like you do for a square and a rectangle. So they broke it down back into pieces that they were very familiar with. They started looking at triangles. So they looked at the quadrilateral shapes and they started seeing, okay, how many triangles do I have in each picture? So if you look, there's two triangles for each quadrilateral. And then they said, okay, well, I know one triangle has 180 degrees. And well, if one triangle has 180 degrees, they're both going to have 180 degrees. So then they said, okay, we'll take those 280s and add them together. And if you do that, you get 360 degrees. So in a quadrilateral or any four-sided shape, you're going to end up with 360 degrees when you add all the angles together. So then they kept going. They started looking at a pentagon. Okay, and they said, all right, this has 5 sides. How many triangles are in that one? And whenever they looked at the triangles, they started from the same exact vertex. So you can't mix and match between. If you're going to start there, you've got to keep using that same vertex to create the triangles. So if they did that, and they said, okay, I've got 1, 2, 3 triangles, and they're all equal to 180. So you could take the time to add the 180 the 3 times, or you could just do 3 times 180, and that gave them 540. So when you're looking at a pentagon, it's got 5 sides, and if you add up all the angles in it, they're going to equal to 540 degrees. So for this one had 2 triangles, so they did 2 times 180 to give them the 360, and this one is just 1 triangle, and that gives them the 180 degrees. So then looking at this hexagon, hexagon has 6 sides, and they picked 1 vertex, and they started drawing from there. And they saw 1, 2, 3, 4 triangles. So 4 triangles times 180 degrees is going to give them 720. And whenever they were doing these problems, they started getting shapes that had a whole bunch of sides. So let's say you had 32 sides. You wouldn't want to spend all the time that it would take to draw all those triangles, figure out how many there are together, make sure your drawing's nice, neat enough so you can count them. So they started trying to find a pattern for how to calculate these values. So for this one they did 4 times 180, this one they did 3 times 180, this one they did 2 times 180, and this one was pretty much 1 times 180. So they started working their way backwards. They wanted to write an equation or a formula that would work for every single problem. So they noticed that the 180 was the same for all the problems that they were doing. So they said, okay, we'll put 180 as part of our rule. And then they were like, oh, well, maybe it's going to be however many sides times the 180. And that wasn't the case, because when they tried it for that triangle, they did it 3 times 180, which is 540. And we all know that triangles add up to be 180, so that didn't work. So then they started comparing, what did I actually multiply it by versus how many sides that they got. So looking at those two, so looking at the 3 and the 1, looking at the 4 and the 2, looking at the 3 and the 5, and the 6 and the 4, they started noticing that the difference between 1 and 3 was 2. They noticed that the difference between the 4 and 2 was 2. The difference between the 5 and the 3 was 2. And the difference between the 6 and the 4 was 2. So to get the number of triangles that are inside of a shape, they took the number of sides, which is represented by the number n, subtracted 2 from it. That gave them the number of sides in the number of triangles, and then multiply it by the degrees. So n is going to be equal to number of sides. And so I'm with you. One more formula that I'm going to have to remember. But if you remember what I just got done talking to you about, that like even if it's a really hard shape where it's got a whole bunch of sides, you can draw yourself a nice square or a pentagon and then draw the triangles, and then remember, oh, it's just going to be the number of sides that I have minus 2, or the number of triangles that I have, which is this one right here, times 180, and that'll give you the degrees. So the type of problems that you could start seeing if they just didn't straight ask you for the sum, these do. We'll go ahead and do these. So the diagram shows a convex polygon. What is the sum of the interior angles of the polygon? So if you didn't remember, you could divide it there and then do 180 for that triangle, 180 for that triangle, multiply them by 2 and get it that way. Or you could use the formula that we have. So the number of sides is 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is going to be 360. So just to double check, looking at the quadrilaterals there, they match, so we're doing okay. Looking at this shape right here, you could get IXL problems that ask you how many triangles are in there, and with those, again, you're just picking that vertex and you're drawing the lines to create the triangles from that same vertex. And then if you, 1, 2, 3, 4, 5, 6, 7. So this one has 7 triangles in it, just in case they ask you for that. But this one doesn't. It asks us, what is the sum of the interior angles? So we're looking at the number of sides minus 2 times 180. So the number of sides, 1, 2, 3, 4, 5. We've got 9 sides minus 2 times 180. So 9 minus 2. Remember, this right here gives us the number of triangles. So if they do ask you the number of triangles and it does have a bunch of sides, or if you have trouble keeping all of the different things straight, then you can just say, okay, how many sides do I have? Subtract 2 from it, and that'll give you the number of triangles that are in your shape. So to get the degrees, we take that 9 minus 2, which is 7, times 180. And that's going to give us 1,260 degrees. So if you would take all of these angles and add them up together, that's going to give you 1,260 degrees. Looking at the next example, they could ask you to find the measure of one of the angles. And usually when they give you these types of problems, they're going to talk to you or tell you that you have a regular polygon. All regular means is that all angles are congruent or the same. And I mean, it also follows that if all the angles are going to be the same, all the sides are going to be the same. but for our purposes, what we need is just the angles being congruent. So in order to be able to find one of the measures of the angles, we have to know what they all are. So if we're going to find the measure of all of the angles, we're going to do the number of sides minus 2 times 180. This one has 6, so 6 minus 2 times 180. So 6 minus 2 is 4. So if we were to draw it, there's 4 triangles in there. So 4 triangles times 180 degrees is 720. So if we added all of those angles together, that would equal to 720 degrees. But they're not asking for all of the angles, they're asking for the value of x, and the value of x is just one of the angles. So if 720 degrees is all of the angles added together, and they're all equal, we could take 720 and divide it by the number of angles that we have. So 1, 2, 3. And then the number of angles is going to match the number of sides. So we're going to take the 720, divide it by 6, and that's going to give us 120 degrees. So this angle right there is 120 degrees. That angle right there is 120, 120, 120, 120, 120. And again, this only works if you've got a regular polygon. If it's not regular, then you can assume that they're all going to be the same. Whenever people do these problems and they do enough of them, they usually point out to me, well, isn't there a way that we could just write a formula for this one too? And I say, yeah, there sure is. You could take this and write it as the number of sides minus 2 times 180 divided by the number of sides. If you want to use that, that's fine. Doing it this way gets you the same exact answer, and it actually is that formula. You're not looking at it as a formula, you're looking at it as bits and pieces of what you're working with. I don't care which way you do it, just whichever way makes sense to you is fine with me. So we're looking to find the value of x. Value of x is going to be one of the angles. So before we can know the value of one of the angles, we have to find the value of all the angles. So in order to find all the angles, we've got to do the number of sides minus 2 times 180. So we're looking at 1, 2. So we've got a 9-sided figure, so we've got a nonagon. So 9 minus 2 times 180. And I'm going to go ahead and use the formula divided by the number of sides, which is 9. So 9 minus 2 is 7 times 180 divided by 9. 7 times 180 is 1260. So there's 1260 degrees. Yeah, 1260 degrees in that nonagon. But I don't want the measure of all the angles, only want the measure of one. And the way I know one is because they put an x in that one. So 1260 divided by 9 is going to be 140 degrees. So the value for x in that problem is 140 degrees. But they could start giving you different types of shapes, like this one right here. If you're looking at this one and this one's called a regular polygon, this one's going to be called an irregular polygon, and they're not going to tell you that. That's what it's called. So if we're looking at this one, they want to know what is the value of v. So v is right there. Well, before when we did these and we had the triangles, then if they gave us like 3 and then 2x plus 7 and then x, the way we found x was we added up all those values and set them equal to 180, because we know that those 3 added together will be 180. It's the same exact idea for this, but instead of setting it equal, adding them all together and setting them equal to 180, we don't have a 3-sided figure. We've got a 1, 2, 3, 4, 5-sided figure. So we have to figure out how many degrees are in a 5-sided figure or a pentagon, and then we'll take these values and add them up and set them equal to that. So first thing we have to do is figure out how many degrees there are in a pentagon. So just to double check, so then we're doing n minus 2 times 180 will tell us how many degrees we have total. So 5 minus 2 times 180, 3 times 180 gives us 540. So all those angles right there are going to add up to be 540 degrees. Well, what are those angles? Those angles are V plus 145 plus 2V plus 4. This one is 2V plus 4. This one is 2V. And this one is 131 is going to give us 540. So we combine our like terms and we end up with 5V plus 280 is going to be equal to 540. Subtract the 280 from both sides, and that's going to leave us with 260. Divide both sides by 5, and V is going to be equal to 52 degrees. Okay, so to double check that that's really what they wanted us to solve for, V is going to be equal to 52 degrees. I don't think they will do this, but they could ask you to find the measures of angles instead of just the variable. If they do that, let's say they asked you to find that angle right there. You would take the 52, plug it in, 2 times 52 plus 4 is going to be 104 plus 4 is going to give you 108. So just to keep an eye out on what they're asking for and make sure whether it's the variable or they're asking you for a specific angle. They could also give you problems where they don't give you a picture and you have to use what you know about polygons and the measures of their interior angles in order to be able to solve. So this one says we have the interior angle of a regular polygon. That tells us that all sides and angles are equal. How many sides does the polygon have? So we don't know how many sides we're working with, but we know that one angle in there is going to be equal to 108 degrees. And that's where this formula that I was talking to you about here, that's where it can start coming in handy, because this formula gives us the measure of one angle. So if you know the measure of what one angle is, in this case it's 108, is going to be equal to the number of sides that you have minus 2 times 180 divided by n. And then it just becomes an equation where you've got to solve for n. So to do that, multiply both sides by n. So you end up with 108n is equal to n minus 2 times 180. So then we're looking to get n all by itself. And right now it's stuck in parentheses. So the way to get it unstuck, there's a couple different ways, but I think most people would see to distribute the 180 first, so that's the way I'm going to do it. So 108n is going to be equal to 180n minus 360. Subtract 180 from both sides. And that's going to leave us with negative 360 is going to be equal to 72. Negative 72n is equal to 360. Divide both sides by negative 72. And n is going to be equal to 5. So how many sides does that polygon have? It has 5, so that makes it be a pentagon. If you want to double check the answer to make sure that you we've got it right and it really is a pentagon, you can do the problems forward. So do the n minus 2 times 180 divided by n, and plug in 5 for n that we found. So 5 minus 2 times 180 divided by 5. So 3 times 180 divided by 5. 3 times 180 is going to be 540 divided by 5 is 108. So the number of angles total in the whole shape divided by the number of sides will give you one of the angles, and that'll be 108 degrees, which matches what we had originally in the problem, so that's how we know we got it right. Looking at the next one, they tell us we have a convex quadrilateral. Remember, quadrilateral means 4 sides, and it has the interior angle measures of the expressions given. What is the value for t? Well, usually when we do these, this is just like this problem, but without the pictures. So it's going to be the same exact method to solve. You're going to do quadrilateral. How many degrees are in a quadrilateral? N minus 2 times 180. So 4 minus 2 times 180 is going to be 2 times 180 is going to be 360. So then you're going to have 11t plus 48 plus 150 plus t plus 45. And that's going to be equal to 360. We know it's 360 because it says we've got a quadrilateral. So combine like terms. 13t plus 243 is going to be equal to 360. Subtract the 243 from both sides, and then 13t is going to be equal to 117 divided by 13, and then t is going to have a value of 9. Looking at the last example, we've got a convex hexagon, has an interior measure angles of the one given. What is the value for S? So we're looking hexagon. So you've got to remember, how many sides does a hexagon have? Hexagon has 6, so we're doing 6 minus 2 times 180. Because we've got, if it wants to know the value of S, we have to use our polygon angle, our interior angle rules in a polygon. Add all those up, set them equal to the total number of degrees in the whole thing, and then solve. So to find the value of all of the angles in the whole thing, we do the n minus 2 times 180. So 6 minus 2 is 4 times 180. 720. So altogether there's 720 degrees in a convex hexagon. Those angles have a value of 150 plus 5s minus 30 plus 150 plus s plus 5s minus 30 plus s plus 48. And I think with these problems, they're going to give you a value for each angle individually, so that's a way to double check. I don't know if they'll always do that. They could combine 2 of the angles together. Hopefully they wouldn't, but 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So there's 6 total, so that's a way to double check and make sure that remembering that a hexagon has 6 angles is right. So then combine all the like terms. 720 is going to be equal to 12s plus 708. Subtract the 708 from both sides. And that's going to give us 12 is equal to 12s. Divide both sides by 12. And s is equal to 1. So there's just several different examples of how they could use the measures of the interior angles of a polygon to ask you to solve for values. We had a couple examples where they just tell you what kind of a polygon that you have, give you angle measures, ask you to solve for a variable. They could ask you to solve for the number of sides given the measure of just one of the angles. They could ask you to solve for just the variable or an angle given a picture. They could also ask you to find the measure of one of the angles in a regular polygon. And then they could ask you for just how many degrees are there total. If you have any questions, be sure to write them down on your paper and ask when you get to class.